So then, now that we've established that for these 2 points there is this linear relationship, so these 2 points are points that we've measured, um, we can also do some other test points and decide that if we take a value, a third value here, p3, we will find that that corresponds to a change in length delta L at this point here, which we could call delta L3. And indeed, if we change the force P1, the load, to any point along this line here, we would find that if we came across from that value to this line and then drew down for this particular sample, which happens to be a perfect sample of a steel rod, we could find that this line represents all the values that we could apply to it in terms of the force, and it would give us all the corresponding values in this change of length delta L. Okay, so if we now imagine that this rod, instead of being L long, let's have this rod which was L, which we apply the force P to. If we now have a rod which is twice as long, that has the same P value, so all of the things are the same apart from its length. The length has changed to a value which is now 2L. Okay, so it's twice as long. Under that force, we will get an extension delta L, which we got from our the relationship that we established here, the graphical relationship here. So delta L. If we now look at this sample, we can see that because this sample, perhaps intuitively you can get a feel for this, that the extension under for this rod here, it doesn't seem right that this is the same extension here, delta L. And in actual fact, we will find that delta L is larger. And in actual fact, if this rod is twice as long, all other things being the same, this delta L, so that's delta L1 and this is delta L2, we will find that in this case, delta L2 for the same load P is equal to 2 times delta L1. Okay. So we've got a problem here in that in this new sample that we've come up with doesn't correspond with this relationship that we've established here. Because we've changed the length, we can't rely on this straight line being applicable to this sample, this particular sample. So then we need to, as engineers, come up with a way of dealing with that potential problem. Okay. Now, what we can see here is for this same value of load P, we are getting an extension which is twice the length, twice the delta change in length. But if we now take a property of this system that we've got here, whereby we say, well, I'm going to, instead of being interested in the change of length, delta L, I'm going to be interested in the change of length as a fraction of the overall length. So I'm going to look at delta L divided by the original length. Okay. And I can now see that this delta L1 for this length 1 here is such that delta L over L gives me some value. Okay, it's quite a small number because this extension is quite small compared to the original length. But if I take that fraction, delta L divided by L, if I now look at the situation here, I have, for the same load P, I have a delta L2 divided by 2L. Okay, and I know that delta L2 is twice delta L1. So here I've got delta L1, here I've got delta L2. The original length was 2L for this case, and the original length was L for this case. So when I now consider the fact that the change in length is delta L2 is twice the change in length delta L1, I can substitute for that value in here, so I can change this, or this is equal to, if you like, 2 lots of delta L1 divided by 2 lots of L. Okay, so I can see here that this 2 lots of delta L1 divided by 2 lots of L is actually the same value as 1 lot of delta L1 divided by L. So effectively these twos cancel, and I end up back with delta L1 over L. Okay, so these, if I measure the property as change in length divided by length, change in length 2 divided by the original length in the second situation, which is twice the first, I find that I've got a property that's common, and we call that property strain, and we give it this symbol here, or I'm going to give it that symbol here in this case here. So if we say that strain is equal to the change in length divided by the original length, and if instead of plotting change in length, we plot strain on this axis here, I now have a strain delta L2 divided by L, delta L1 divided by L for this situation here. If I now change the value of L, I will get a different delta L, but this value delta L divided by original length, so change in length divided by original length, is going to be the same for or something that I can measure commonly for all samples, no matter how long they are. So by measuring strain, or by plotting strain on this axis instead of change in length, strain being change in length divided by original length, I've now eliminated that potential problem whereby if I change this variable, the original length, I have a problematic situation. Okay, so this equation now represented by this line on this new set of axes, where I'm plotting, instead of change in length, I'm plotting this value strain, is now correct for all samples, no matter what their original length is. Okay.